Welcome to Study Loop.
Okay, here we have a capacitor. Let me write that here. C equals to 2 microfarad. And if you want to convert this into SI, this turns out to be 2 into 10 to the power minus 6 farads, right? And we have another resistor R, which is 6 kilo ohms. And if you want this in SI, this is 6 into 10 to the power 10 to the power 3 ohms. So they are connected in series with an EMF E equal to 90 volts and negligible internal resistance. So the circuit is completed at t equal to 0, right? Now, number A asks us, just after the circuit is completed, uh, what is the rate at which electrical energy is being dissipated in the resistor? So first, for the power dissipation, we need the current, right? So the current in an RC circuit is given by current I at any time t equals to I naught. That is the current when time, that is the full current, the maximum current, that is at time t equal to 0, and minus t upon t is time, and R is the resistance, C is the capacitance, right? So at time t equal to 0, at t equal to 0, so I is equal to I naught. Now that is the maximum current that flows, which is equal to E upon R, considering that no current flows through the capacitor at the beginning, right? So the maximum current that is flowing is 90 upon, what is R, 6 into 10 to the power 3. So this gives me I equal to 0.015 amperes. Now we need to calculate the power dissipation. So power is equal to I squared R. Now you know the value of I, you know the value of R, just like this in here, you get power P equals to 1.35 watts. Alright, yeah. Now question number B asks us, at what time t is the rate at which electrical energy is dissipated in the resistor equals to the rate at which electrical energy is stored in the capacitor. So the rate at which electrical energy is dissipated in the resistor is simply I squared R, right? So our condition is that I squared R, the rate of dissipation in the resistor, should be equal to the rate at which electrical energy is stored in the capacitor. Now, the energy stored is actually half of the charge in the capacitor upon squared upon capacitance, right? Now the rate is d by dt of that, right? Where the charge also varies exponentially and given as q is equal to q naught 1 minus e to the power minus t by rc, where q naught is the full charge, right? With charge when the capacitor is full. Okay, now if you differentiate this, so 1 by 2c is constant, that I take this out, then 2q, q squared derivative is 2q, and we are left with dq by dt, right? Now on the left hand side we have I squared r, and on the right hand side we have, let me write that here, I squared r equals to q by c. Now dq by dt, the rate of change of charge is what? Current. So I. Now I can cancel out I on both sides. So this gives me IR equals to q by c, right? Now what can we do? What we can do now is just plug in the values of I here. So this becomes I naught e to the power minus t by RC times R is equal to Q naught. So Q by C, right? So this is equal to Q naught 1 minus e to the power minus t by RC upon C. Isn't it? Yes, it is. So what can we do next? Now I naught into R, I naught into R and Q naught by C. So what is I naught into R? The maximum current that flows into R is E, right? So e to the power minus t by RC is equal to Q naught by C is also E, the maximum charge of our capacitance. So 1 minus e to the power minus t by RC. Now E get cancelled out, and if you multiply by e to the power t by RC on both sides, then this gives me 1 is equal to e to the power t by RC minus 1. So 2 equals to e to the power t by RC. So t equals to RC log exponential 2. Now you know the value of R, you know the value of C, you know log E2. Just calculate those all and plug in here. Then this gives me t equals to 8.31 milliseconds. So we are done with part B of the question. Now let's move on to part C. Okay, so for the part C, the question is asking us to calculate the energy dissipated in the resistor at that particular time, which we calculated in part B, right? So in part C, first let us find the current. I is equal to E upon R e to the power minus t by RC. So power P equals to I squared R. So E squared by R times e to the power minus t upon RC. So I just used here the formula P is equal to I squared R. Alright. Okay. Now you know the value of E, you know the value of R, you know the value of T, you know the value of R, you know the value of C. Plug everything in here. This should give me 0.338 watts. So this is the power dissipated in the resistor at that time. And this is the solution to this question. Thank you for watching.